I know it's a little hard to see in the dark, but it's right behind me. John, this air conditioning on a warm day will change the temperature about 40 degrees inside this cab.
Well, it's been one of those hot summers. This cab is drawing a lot of interest.
All right, well, when I set out to buy this Curtis cab, this video was one of the things that impressed me and inspired me to go out and spend the kind of money that I did to buy this. And when I got it home, I made a video last week, and in that video I said I would probably do a load test on this to see if it will actually drop the temperature in the cab 40 degrees. Well, the first thing we have to do in order to do a load calculation is we have to figure out how many square inches of opening do we have in the supply grill. Now you look at that opening, you say, well, they're oblong slots, it's impossible to do. Well, it really isn't. You count up the number of slots, and there are 12 long ones, and then there's 4, 4, and 4 of the shorter ones. And all you have to do is subtract the arches. What's left is a rectangle. That's easy to compute. And then you take the two half circles, put them together, that makes a circle, and you do, pi times radius squared, and that gives you the square inches of those circles. Add them together, you get 28.907. Okay, another thing that I wanted to know was what was the volume of the cab? And you just take the width, height, and depth, and I had to do it in two pieces. The first set of numbers is just above the seat pan. The second set of numbers there is all the way down in the footwell. And so it comes out at 67.236 cubic feet of space. All right, the next step in the process is to measure the feet per minute. And I used a digital anemometer to do that. It's a very accurate one. And on low, it got 413 feet per minute. On medium, 492. On high, 610. And that's done with a dry coil. I'm giving Curtis every advantage on this because when the coil gets wet, all those droplets of water will increase the static pressure and it will reduce the airflow some. So this is all my test data. There is a problem with the low test data, and I'll talk about that in a minute. All right, now that we've done all that work, we can take the total square inches of the supply grill, which is the 28.9, times the feet per minute, which was 610 feet per minute, and that's with a dry coil. Gives us 17,633. Divide that by 144, and we get 122.454 CFM. All right, so using that in our BTU calcs, we use the wet bulb temperatures on the return, 69.2. The dry bulb was 85.1. And then the supply air wet bulb is 49.6. And we have to convert those using an enthalpy chart to get the BTU per pound, because we want to calculate the total workload, not just the sensible, in other words, what you feel, because condensing moisture takes up quite a bit of energy for an air conditioning system. So we use 33.42 for the return air, 20.08 on the supply, gives us a differential of 13.34 times the air constant of 4.5, gives us a BTU per hour of 7,351 rounded up. Okay, so the first issue I want to address is the statement that John Davis made on the video that we showed at the beginning, saying he could drop the temperature in the cab 40 degrees. If you look at my dry bulb temperatures, 85.1 with a supply of 51.6, 33.5 is the delta. That is not 40 degrees. And we're going to take another look at another thing that he says in the same video, and then we're going to challenge that.
Humid day, we get a temperature delta of just under 40 degrees.
Wow.
So it really behaves as we intended it to, like your F-150 air conditioner.
Okay, John, I've been to New Orleans in my F-150, and this mower doesn't cool anything like my F-150. I'm sorry. All right, let's go back to trying to test this on low speed. The problem was I couldn't get the discharge temperature to stay constant, because when you put it on low speed, it doesn't move enough air and the compressor kicks in and out, just like an automobile will do, because the evaporator temperature drops down and the pressure in the system drops down.
A little bit about the air conditioning itself. The outside temperature is in the low 80s. very, very humid. In fact, it rained a bit earlier this morning, so the humidity is very high. The sun is bright, so it's not really hot, but the windows and all are, you know, I mean, it feels hot inside here because of the sun's radiation. The air conditioning's not able to freeze me out, let's put it that way. But it does keep it relatively cool. It feels good on my back, and again, the air conditioner is behind me, as you saw, and there is a little flipper that I can control where I want that air to go. If you put that flipper up horizontal, then the air comes over your head and comes down more in front of you. I like that when it's a little bit cooler. When it gets really hot, I just point it right down on my back and just say, well, it's not going to be cool overall in this cab, but at least my back is going to kind of stay cool, and therefore I'm going to kind of stay cool. So that's how I run it. Sorry about going crooked there. I was looking at the camera to see if everything was running, but I can't hardly keep everything here at the same time.
Well, I borrowed that footage from Tractor Time with Tim, and that's Tim and his wife Christy, and they do a really good job with their drone. They can film things that I can't film. I was going to do some of that myself, but Tim has a lot of good things to say about the machine, and he's a pretty straight shooter. So y'all make up your own mind, not trying to persuade anybody one way or the other. But I've done the test. It is what it is, and we'll catch you on the next one.